So one of the biggest challenges with existing solutions, meaning you have, for example, you have a typical. Let's just look at the slide, and even though it's coming at the last. Let me just go to this slide now. Moment. Okay, so in a big data solution revolving around Azure, more often than not, you will see this kind of architecture. Mostly similarly, 60 to 70% of the time, you'll have a few other services. By and large, you will see this. So you'll have Azure Data Factory to be used to pull the data, load it into data storage, something like Azure Data Lake, and then you have Databricks, which is the best possible Spark engine available, which does all the massaging, and it lets you to explore the data, run your ML, machine learning, and find the insights and do all that. And then you will, once you are absolutely convinced that okay, this is the one that I want to send to reporting, so then you'll push it into data warehouse, which acts as the serving layer, which is optimized for running heavy analytic queries. So the result is stored in data warehouse, and then the result is displayed in Power BI. So this is the typical flow that you have. Sometimes you may have Azure Analysis Service in a few scenarios somewhere over here, or if you have sometimes you can have Cosmos DB if your workload is on things like if it's more unstructured data that you want to maintain and you don't want to have tabular format at all, then you may wish to go for something like Cosmos DB and so on. So by and large, you will have this sort of flow. But the biggest challenge, how I wish this session was. Let me just pause for a moment. What do you think is the biggest challenge in this particular framework? You just open up your mic and just say, I'm all good. Anyone? What? Okay, let me keep it to the screen so that one moment. It's all right. You can just say, what do you think is a challenge? Some of you have played with these stuff. So feel free to, in your opinion, what was most challenging in doing these kind of things?
For me, basically, when I tried this was major challenge I feel was data means like means like data types transformation,
Okay.
and yeah, so
Okay.
that was
Okay. Data types is one. Sujay has also said pulling it from different sources. Yes, Asif has said data types. Yes, I agree. So one of the that is one challenge. And in addition to that, one challenge which we would have all faced is tying all these together, meaning establishing the right connectivity across all these and managing them and troubleshooting and managing everything together is a significant challenge. It is a challenge even with even currently with customers using previous version of Synapse. Okay, so when making all these into one single bucket and maintaining them together, even though it is much better than several other platforms, okay, other cloud platforms, still I would probably say one of the challenges stitching all these things together is a significant challenge. What Synapse actually does is, now data factory is inside over here. It works very closely with data lake. Like you need not have a separate Databricks. You have pretty much almost the same engine inside Synapse itself, and then we have our good old data warehouse inside it. So all these things are combined right inside this one single service, which makes it a lot more easier to maintain and to work out something, to gain insights out of the data, to combine across multiple sources, and then to manage it makes it much easier. So today my objective is is to show you, what I want to do now is I want to take a simple CSV and I want to take it all the way to Power BI in this next 30 odd minutes or so, and also explain the stuff I want to cover. So that's the intention. If I can do that, then it is indeed pretty easy, right? In a session in 30 minutes, if I can take it through all these layers and finally see it in Power BI, then it is cool, isn't it? Okay, let's see if that can be done. So first thing that, as I said, first I want to talk about Synapse SQL. So Synapse SQL, before I get into it, what is this Synapse SQL pool? So all of you, I think, are familiar with SQL Server, right? So you have SQL Server, which is capable of storing relational data, and you can put massive amount of data into it. It is able to handle. Then what is Synapse SQL pool different from it, or what is Azure SQL data warehouse different from it? So one of the fundamental difference between a traditional SQL and this data warehouse is it supports MPP architecture. These are distributed databases, where the data is actually distributed across multiple machines, and you have multiple CPUs running in parallel to execute one single query. When I submit a query, it is capable of splitting it into across multiple nodes. You have multiple mini SQL servers running in different machines. It takes the workload, splits, runs, pushes the data back, and then it is presented. So, and the data is all optimized for analytic workload. How do I say it's optimized? When I'm running it in data warehouse, the data is by default using column store, or or it is by default running on columnar storage. In traditional SQL, by default, you have row store based, which is a lot more useful for singleton queries or queries that affect few bunch of rows. Whereas when you talk about analytic workloads, it's one of the key things that you need is maintaining the data by columnar or storage. So that is there in Azure SQL Data Warehouse, and that is there in Synapse SQL pools as well. Okay, so within Synapse SQL pools, you have two categories. One is serverless, other is dedicated, meaning what these two are. So dedicated means is our good old Azure SQL data warehouse, where you create the services, as you spin off some amount of nodes, and then and then the service is running. You submit the queries, and then the workload is distributed. Results are coming. So you can pause the service when you don't need it. You are billed only when the service is actually running. So you can pause it when you actually don't use it. You have the serverless mode where there is no service that's running. So when the query is submitted, it automatically goes and spins off whatever number of nodes you need. You can submit a SQL query. It can automatically go and spin off whatever amount of nodes it needs, and then it can run. And once the query is executed, and you only pay for the amount of resources that the query actually consumed. So that is serverless, that is available in Gen 2. Earlier Gen 1 and was just Azure SQL Data Warehouse, where you had only the dedicated component. Now with generation 2, you have the serverless and the dedicated. So this is the architecture. So the data can in both dedicated and serverless, the workload is distributed across multiple nodes, and then it talks to the Azure storage and pulls the data. Let's actually go and see how these things look like. Any questions or anything that the team wants to say? Meanwhile, yeah, following me so far?
Yeah. Hi everyone. If you have any questions, so you can unmute or can ask, or maybe you can put in the chat box.
Yeah, I would encourage you to unmute and ask, because I may not be seeing the chat box. Don't worry about interrupting me. So just unmute and just ask. Happy to take your questions. Okay, let's go into Azure portal and do some work. Okay, so to get started, so let me just create a resource. Azure Synapse Analytics. So typical stuff, give your user, give a particular area that you want to resource group RG, and then give a unique name, probably WS1 maybe, and then I need for this thing to work, for Azure Synapse workspaces to work. First, you create something called workspace, which is like a container which contains the SQL pool, the pipelines, the notebooks, the Apache Spark pool. All these go into the workspace. So first we create the workspace. So, and then you have, okay. So for this, I would need to create Azure Data Lake account as well. So have a Data Lake account. If you don't have one, you can just give a name, create new. It's a Data Lake Gen 2 account that gets created, and it will ask you to give a file system name inside the account name. So which is like just like a directory in your typical Windows machine. So, and then it also asks for the SQL user account and password. So these two are also needed. So the account that you would use for the SQL pool. So the SA account and the password. So once you give these, the service typically gets ready in about 2 minutes. But in the interest of time, I have a workspace that has already been created. So once I create it, I would get something like this Synapse workspace over here. The storage account that I created came in over here. These two comes once we spin off some sort of Apache Spark pools and the SQL pools once we spin it off. So once I create them, so I have what you typically see is a built-in serverless SQL pool. You won't have a dedicated pool by default. I have already created it. Again, in the interest of time, I don't want to spend 2 minutes staring at the screen. So it doesn't take that long, to be honest, but I just created it so that we can cover the key items. Okay, so I have the built-in pool, which appears by default. You don't get the SQL pool and the Spark pools till you create them. So once you do that, so typically, so initially till you start something, by default you're not charged anything. So to create it. So after I do that, next thing you would want to do is to create a dedicated SQL pool, which is the typical data warehouse that you want to have. Let's cover off the dedicated SQL pool and the serverless aspect of the SQL pool first up. So So if I go and click on the dedicated SQL pool, if you are familiar with Azure SQL Data Warehouse, then you would know this. So it is like creating a Azure SQL Data Warehouse database. So over here, or rather Azure SQL Data Warehouse instance. So over here, I specify the SQL pool name, meaning I can give it some name, keep it to minimum. You can go up. So depending upon what level you pick, that many number of distributed nodes you get, up to 400 or DW 500 you get. You don't up to DW 400. It is only one node. After DW 500 and so on, you get multiple nodes and so on. So for DW 6000, it goes up to 12 nodes if I'm not wrong. 6000 is 5000 is 10 nodes. Yeah, 6000 is 12 nodes. So for every 500, you typically have a additional node.
Hi,
Okay.
Nagaraj. I have
Go
one
ahead.
here.
Yes, please.
On in one node, basically how many? Because as I understood when I was going through this Synapse analytics before, so whenever we compute the transactions on the data on the data warehouse, so it distribute the queries into 60 multiple 60 queries. So it is for the one node, or it means like it's for for different
Okay.
nodes.
Okay, let me correct this over here. So it doesn't distribute the query itself into 60 queries. Okay. So
Mhm.
so when you create a table, so
Yeah.
inside each node you have 60 distributions, meaning by default inside each node it will
Okay.
distribute the table into 60. It's like simple SQL partition where inside it each node you have multiple distributions. Those 60 that you are calling is distributions, number of distributions. The nodes are on top of it. You have actual servers running. So if I, for example, in this particular case where I'm having 100, what I would have is only one node. But inside that single node, for each table I create, it will be distributed into 60 different distributions. Yeah.
Oh,
So by default, it will partition the data and split it into like small 60 tables inside each node. And the query will be split when you have multiple. If I have over if I have two CPU nodes or three CPU nodes and so on, yeah, or three compute nodes and so on.
oh, okay. Okay. Thanks.
Yeah, cheers. Okay, thanks, Asif, for making me feel I'm speaking to a real audience. So sometimes the challenge with these remote sessions, which I have been delivering almost every day since last 1 year, so is sometimes it feels as if you are on a monologue. Okay.
True. True. Yeah.
So it's like talking to the mirror. There
Yeah.
have been cases where I have had audience where there is absolutely no response after talking for almost 1 day, not 1 hour, 9 to 5, and then I asked them, okay, just just shy, that's all right, that's fine, absolutely fine. So and then I ask, all right, there will be two or three people. These are specific to few customers, or there will be two or three people in the call. So just ask their name and do you have any questions? This was something you mentioned earlier that's interesting for you, and then there will be no answer, and then the person would have already gone somewhere.
Yeah.
So it has happened more than once, and I'm glad this one is not in that sense. Thanks a lot. Okay, moving on. So create the dedicated SQL pool, give the SKU, and yeah, and once you do this, this also takes typically about 3 minutes, 3 to 4 minutes max. So the SQL pool comes up in about 3 minutes, so which is good. So once I have that, I have the SQL pool, I have a serverless pool, which is built in. I need not do anything special for it. You can create any number of SQL pool depending upon how strong your credit card is. So so dedicated pools, as you saw, so they come for each capacity. The dollar value actually goes up, so use it wisely. Okay, so
Hi,
one
Nagaraj.
important thing. Yeah, go ahead.
There is one question here. If you
Yeah.
created a serverless, can you convert in later dedicated, or how about other way around? You know, from Christine.
Okay. Okay, one point is you have only one serverless pool that is built in. There is nothing called converting it or doing anything to it. Okay, the dedicated pool is like a server that is actually running. And so there is no chance of converting from A to B. And if you understand, if I explain this completely, then you will understand that you not need such a case where you actually need to convert from A to B or serverless to dedicated and dedicated to serverless. Thanks, Christian, for that. Just hold that question for a while. Let's get through the session. Probably after that, if you still have that question, shoot it again in and I will try to explain it more. Okay, let's. Okay, we have this now. One thing I have is I have uploaded one little file called weather.csv inside this container which I have attached with Synapse. So this particular, so I have uploaded this particular file which I'll be using during the demos. It is a little simple file. You again, in the interest of time, I wanted the results to come a little faster. So okay, so now what I'm going to do now is I am going to use serverless to query uh, do whatever I can. Yeah. Okay. Or yeah. Or let me do serverless first. Let me show how it works with in dedicated, and then probably I'll switch to serverless. So first let me get started with dedicated pool over here. So first thing, how to access your Synapse workspace. You can either click on this open Synapse Studio or click on this workspace URL. Let's do this. So it opens up this interface. And then once I click over here, I see, okay, I have these 4 tabs, just the home, which is more like an intro of sorts. And then I have data, I have develop where you can typically have your notebooks and stuff. Integrate is the pipeline piece, monitor, and some manages to plugging into a few other services. So let's start from data. Over here, I have a SQL pool because I have a SQL instance created over there, and then I have yeah I have the default Spark pool because I created a Spark pool already. So let's look at this little later. This is, as I said, is our good old C Azure SQL data warehouse. So if I want to run queries, or I can straight away do it as usual from over here. So it will tell me which pool do I want to. I am at to start my Synapse dedicated pool. Let me start it. So what are the kind of things typically you do? So what you may want to do is you think of the architecture that we spoke earlier. So let's say you have some data in blob storage. So Synapse can be used to ingest the data onto Azure SQL data warehouse, and you can try to gain insights out of it. So I have this particular zip file. Well, it is not a storage account inside my subscription. It is a storage account stored elsewhere. I can query this data stored in a blob storage as long as I have permissions against this particular storage account. Say that I want to unzip on the fly, give whatever parameters that are needed, and give the delimiters and so on, and then the data will be ingested inside it Synapse. So this particular tab, and it is pretty fast in terms of doing the ingestions. So this particular zip file is about 150 MB, so flowing through the internet, and it will be uncompressed on the fly, and it will be loaded into Synapse. So you have the option of doing this as I have shown, ingesting it directly. You can create something called external tables, by which you can create a link to that particular file, and you can run queries on top of it. Okay, so you have both the options. If the data is already ready, then you may want to ingest it into Synapse so that it can be consumed at other layers. If the data is still under prep, then you may want to create something like a external table, run some queries on top of it, and then ingest it into a table in Synapse. So it took about a minute for it to do the job. I think it would have ingested compressed is 150 MB, probably the actual data size would be much bigger than that. How many rows did it do? We were to check. So about nearly 3 million in less than a minute, and I'm doing this with a very basic basic skew. Higher the skew, faster the performance. Okay, we have quite a few things to cover. Let me just quickly move on. And now this is the typical Synapse pools. So let's say I want to use something like a serverless pool. What is the use of serverless pool? Serverless pool lets you to explore the data on the fly. It you you can, let's say you have the data stored in Azure blob storage, or like I have shown. Using serverless pool, you can directly interact with the data without actually spinning any sort of resources. So let's right away look into it without wasting much of time. Okay, so so over here, when I am connecting to built-in, does anyone want to say anything? Okay, yeah, thanks. So when I'm connecting to the built-in pool over here, then I'm connected to serverless, meaning I haven't created any sort of resource. So what I'm going to do is I'm going to directly run this particular query. So this is talking again to a completely, it is talking to another storage account stored elsewhere. As I said, you can also run any blob storage account that is there in your subscription or something else elsewhere as well. So using serverless, I can do the same thing, meaning I can, but as I said, because it's serverless, I'm not having any storage on my own over here. So I'm talking to some other storage account. So you can do read-only queries against any blob storage or anything, and you can get the data. You can define external table, but you cannot ingest the data onto any other place. So I have, so on the fly, it would have read the data. If I go to monitor, And if I see blah, 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 hang on. If I go over here, it tells me how much amount of data it processed just now. So why this is important? In serverless, what you are built for is the amount of data that it is actually processing. Meaning, for example, if the charges, if I process 1 terabyte of data, the charge is $5. If I don't run any queries, no charges. So that's the way it works. The storage, of course, you pay separately for wherever the blob storage or wherever it is there. So, but for the compute, it purely depends on how much of data that is being processed. So the query I ran, it consumed about 350 meg and and yeah, that's it. So the charge for that would be fairly minimal and so on. So serverless, as the name indicates, you you can run read-only workloads against the various data that's stored in data lake or any other blob store against a data lake Gen2 account and so on. Now let's also do something more. Let's now quickly look at what Spark pools are. So for folks who are familiar with Apache Spark, so you can sorry, for people who are familiar with Azure Databricks, so Spark pools are in some sense similar to it, meaning you can create it Apache Spark pool to do to run in in Spark clusters which distribute the workload across different nodes and which is optimized for doing analytics in memory, and it is a super powerful big data engine. Okay, so you can run Scala, Python, and all those whatever, all Java, and all these typical languages that you would use to handle big data workloads. So if I go to Apache Spark, if I'm it as usual ask for a name, and then you can pick the kind of machines that you need. So you want a 4-core machine or 8-core machine or 16-core machine. And you want auto scaling enabled, meaning number of nodes are decided on the fly. Again, Spark pool is in some sense like serverless. Number you don't you pay only when you use it. You don't pay all the time. When your queries are running, depending upon how heavy the query is, you need to pay. So over here, you can say minimum to maximum number of nodes, just like you would do in Databricks. And then you can also say auto pause. If there are no queries that are running, then it can be in for 15 minutes, nothing is running, it can automatically shut down. So in that way, you don't pay all the time, right? So you pay only when it is active longer than 15 minutes, or you can reduce the time if you want to aggressively cut down your cost. So it can automatically scale depending upon how much of workload that you're using, and it can also when it doesn't run, and still there may be charge for the storage and a few other things. So completely pausing reduces the cost a lot more effectively. So very little administrative work that needs to be done. So it is fairly simple and straightforward to create. Again, this also takes roughly about 2 to 3 minutes to spin off your Apache Spark pool. You can create a number of Spark pools inside one Synapse workspace, and you can give individual users different levels of permissions, and you can actually ensure You can give permissions against one pool, not give permissions against other, so that you can manage the compute and the cost a lot more effectively. Talking about cost management, and with serverless pools as well, you can actually set, you can set a particular limit to amount of workload a person can actually run. For example, if I go over here, I go to manage pools, and then I see the built-in. So I can actually set, I click on this button, I can actually set daily only X amount of GB of queries can be run. So that weekly you can set this limit and so on. So you can do this to ensure you have a cap on the total cost that you are hitting. Okay, now let's look at Spark pools. Okay, so when I come over here, let's go to this place. I have the default Spark. So I go to data. I can, if I click on browse gallery, and there are lots and lots of data that you can play with. You can click any of them. For example, let's say if I pick this New York safety data or something. So I add the data set. When you say add the data set, it comes in over here, and then it appears over here as sample data set. So if you notice over here inside data, I have the sample data sets which are external, which I have just linked them, and I have the one that I have in my own machine as well. So what I can simply say to use Spark pools is I can just do this, go over here and say that at say new notebook, load this particular blob storage uh, onto a data frame. So once I do that, it automatically picks up a Spark. So I pick up the Spark pool I want to run this against, and then I can simply pick up which is my favorite language. I have I have the options of Python, Spark, .NET, and Spark SQL. So I can use that to start exploring my data. Like, instead of using this notebook, let me use the one that I already prepared. So I mentioned that I have a blob storage over here. So let me run. So what I'm going to do is I'm going to read the data from that particular storage account. So it takes a while for it to start, not the Spark pool to start, for the processes to first time kick in. So it takes about 2 minutes. That's something I cannot work around. So let it start. And then once it starts, I'll be able to use PySpark or whatever my language Scala at each cell. These are notebooks pretty similar to what you see in with in Databricks. So you'll be able to use them and you will be able to play with your data. So once it comes up, once I load the data onto the data frame, what I'm going to do is I'm going to create a database inside Spark. You can create databases inside Spark as well. There, and you can create tables inside them. They are called delta tables. These tables are like your SQL Server tables or like your data warehouse tables, but you have it behind the scene. It is stored as SparkQ files. SparkQ files are are simple text files, but pretty much optimized for you to directly interact with it. You can do things like infer schema, meaning you can infer the schema on the fly, load it onto your table, and then work with it fairly seamlessly. Let it come up, starting the Spark session. So once it comes up, the data is fairly small. Only thing is it takes a while for it to start the session. So what we saw is we saw a bit of serverless, we saw dedicated pools. Now we are looking to the Spark pools. So this particular notebook, what it's going to do is it's going to talk to the CSV. I have the weather.csv, whatever, and then we are going to store the data inside. Yeah, the session is ready. Good. We are going to store the data inside Spark DB. So we'll write it into, we are going to store the data inside Spark DB, and then we'll filter something, do something to that table, and then we'll ingest it into our data pool. So that's what we want to do. So once this is done, what we will do is we will schedule it in a data factory pipeline, and then we will try to see the results in Power BI. So in the next 10 minutes, 10 to 15 minutes, hopefully. Yeah. Okay. So now I'm able to read the data from my CSV. You would see I didn't specify how many cores. When we created the Spark pool, it was 3 to 10 cores. So it took 2 nodes. So sorry, we had 3 to 10 nodes, min to max. So it took only 2 nodes because the minimum is 2 nodes. So the file is fairly small. So it took just 2 nodes. And then max is, and that's the reason you have 8 cores, because a single node had about 4 cores over here. So let's create a table and let's save this data frame. This entire file was loaded into your data frame. And then let's save it into a Spark table. They typically call this delta tables. Yeah. So let's save it over here. Should be fairly fast. Okay, done. Almost. Okay, it's done. You can, one of the coolest things is you can visualize the data on the fly as well. So I can just say chart, and I get these cool visualizations over here. I can, for example, it talks about weather data. So let's say I want to see like rainfall and let's say the temperature, max temperature. So and let's say I want to see that using a line chart aggregation. Let's say by average maybe. I said these two as key. Sorry. I think the key is not so important over here, whereas the values are a lot more important. Yeah, fairly easy to look at the trend. Does that have a correlation? Yeah, looks like, obviously, because rain, when you have rain, you expect the temperature to go down. They do go have a fairly similar progression. So you can fairly easily visualize the data using notebooks. I can save it over here. If I start saving it over here, then I get to see it inside the data as well. So if I go over here, if I refresh, then I just need to refresh it on right on top. Heck, I think I made a little. Okay, so I'll show the tables shortly. I don't want to lose my session. Hopefully I didn't. And then I have, let me show the Spark tables, or I can open up here. Yeah, I can open up a new link. Team, if you, would you mind giving me 10 more minutes? Sure, possibly. 10. I hope to wrap it up by 8:10. Is that a problem?
Sure, sure, no problem. I think let me check.
Okay, so we see that data. Let's say I want to do some more work with it. I want to filter it and save the table inside my Spark database. I can always do that too. Okay, so finally, so yeah, the data is there. Just to confirm that the data was there. Can I can see the data. I just filtered by humidity at 3 p.m. more than 40 and then saved it. So let's say I find out that the data that's more than 40 for humidity is a lot more important. I extract the data and I want to save it inside my Azure SQL data pool, which is the data warehouse. Let's say I want to do that. So I can fairly easily do it by Spark using Synapse SQL, this particular function, load it into a data frame and then write it onto the data warehouse. So this will create a table inside my data warehouse. Okay, so I have all these things done over here right now. So once I do this, so I will get all my, let it do. While it does, let's go and look at how these things actually look out here. So I see the new database that I just now created over here. I see the tables I created from the notebook. So these in brackets say Spark. These are Spark tables, Delta tables. And I also see the new table that the trip was the one that we created earlier and the weather one, which I just now ran. So I have all these. I didn't do any fancy linking or anything. All I did was, if you notice over here, I mentioned my data warehouse name dbo.weather from a notebook. Just mention the name, bang, it goes right into my data warehouse. The blob storage, I had the permissions. I created it inside Synapse. All I need to do was just click on the link. I got everything over here. I'm able to visualize. I can do, imagine if you're doing a real data exploring or something like ETL work, you can run. I'm using PySpark out here. If you want to do SQL, you can do that as well. Meaning, let's say, let me add one more cell out here and say code cell. And then I just want to say star SQL. Then I quickly switch to this cell will be executed in using SQL scripts. So I can just say select star from Rod SQL, this particular, the weather.humidity for that matter. Weather.humidity. Then I can start playing with this too. Yeah. So I can directly talk to. No, there is no need, the necessity that I should only stick to PySpark. I can switch my language as and when I want. So I can do all these, which is pretty cool. And next up, what I can also do over here, I can schedule this notebook inside Data Factory again in a click of a button. So, okay, so I go here, say add to pipeline, say new pipeline. Automatically, what it does is it creates a new pipeline, a Data Factory pipeline over here. Change pipeline to, okay. So, and then say validate this guy. So this particular this task is called in Data Factory. This is a task to run notebooks. Automatically, it gets created. It gets linked. If I want to do something more complicated, I can pull in something like a copy task or a data flow. If you are familiar with data flows for moving the data around and so on, so you can do all these stuff, drag and drop, treat it exactly like you do inside ADF. So let's publish this guy, and then we can schedule this as well. I can say if I want to create a schedule to run this, I can do that over here, create a new schedule over here, or I can just run it now. The run now takes few minutes because again it needs to kickstart the 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 session and so on. Okay, so while that happens, let me quickly go over here and drop this table. So because it tries to create the same thing, the notebook was creating that. So before it gets the session, let me go ahead and drop it off. Okay. Okay. So now the pipeline is running. Let it run. It takes 2 minutes. Let it run. So what we want to do now is, so it will write some data into this weather table. And then what we want to do is we want to see the data out of Power BI. That's the final thing. So in notebooks, I can make change. I can do the ETL. I can explore the data. You have the visualization. You have data flows if you want to. If you are more, if you like that drag and drop and you don't want PySpark. If you are completely into SQL, like many of us are, then you can either use star dot. You can use Spark SQL the way I did, percentage SQL, and play with the data. Or one more thing which I wanted to show was you can also use serverless pool to talk to the delta tables as well. Meaning I can directly query this weather.dbo.humidity is the delta table that we just now created. I can talk to that as well, which is again pretty cool. Meaning all I have is a storage account, and I have created a Spark pool, and I can run our good old SQL queries against it to explore the data and also do some visualizations as well, like we did earlier. So, which is very interesting again. So over here, I'm just using the serverless one, which is cool. Okay, so now I have already exceeded my time. So let me quickly show how you can link it to our favorite tool, Power BI. How many Power BI fans in the room? I think all, isn't it? So I go to manage, click on link services, click here, say new. It says connect to Power BI. Okay, yes, happy to connect. And I need to create a, okay, let's let me, never mind, or let me pick up. It shows the various workspaces that are there in the same subscription, in this particular subscription. So if I go to, let me go to powerbi.com. let's quickly create a workspace. Synapse SQL. Okay. Discord. So let me quickly link it to Power BI over here. Say you Synapse DBI. Synapse, not it. Have you refreshed, my friend? Yeah. Okay. I see the workspace that was I'm trying to hit. So I have this workspace over here. So created. So now my Power BI is linked with Synapse. So let me click on it to do some more stuff. Let me go back to data. Okay, I need to publish this so that it goes. Okay, so let me go over here. Good. Let me say and then over here. Yeah. So under develop, I see Power BI. So can go over here. Click on Power BI datasets. After I link, it comes up over here. I click on Power BI datasets. Say new dataset for integrating it. So it says the file. It says download this data file, which links to the data pool that I have. So it is establishing a connection to my data pool. So I should see the table if the job was successful. Yeah, if not, while this comes up, we can also take a look at the job. Close, please. You can see it over here. So look at, you can go back to monitor over here. Pipeline runs. Yeah, I can see the weather table. So I can see the trip table. I can see the weather table over here. Yeah, job was also successful. As usual, typical Power BI style. It asks me direct query or whatever, and then I'll be able to publish it onto the workspace. So I have already overrun my time. So hopefully I was able to demonstrate that we can plug in all these things fairly quickly together, and we can see the data inside Power BI. Yeah. Hope you are getting the gist of it. You have a video recording, so hopefully you can play it back and forth. So to see what are the capabilities are, just to summarize, you have dedicated pools, typical data warehouse. You have serverless, which can do read-only queries, run read-only workload against blob storage. You have Apache Spark pool like Databricks, all very easy to plug in. You have Data Factory, data flows, again very easy to plug in, and then Power BI, you can link it up. Yeah.
Thanks, Nagaraj. Really nice session. Hi, everyone. If you have any questions, so you can unmute yourself and can ask, or maybe you can put the questions in the chat box.
So yeah, I can see the data over here. I can start visualizing and so on. Yeah.
Yes.
Okay. If let's see, any questions, team? Yeah,
Uh,
Sarah.
Not yet, but I have one question. Maybe
Yes.
I did some already. Okay. Basically, when we means initially when you have created the tables with the script, so means like suppose we have a historical data or we have a data from the live from the IoT or
Mm,
somewhere.
mm.
So what type of tables we need to create? Means like how exactly? Because as I was going through before, so there are a couple of type of different tables in Synapse Analytics. Like there are round robin, and there is
Okay.
also hash mapping. Yeah. So
Okay. Sure. Uh, that's a question that's pretty focused related to dedicated SQL pools. Okay. So
yeah.
you can have the way you want to replicate the table inside dedicated SQL pools is you have three options: hash match, hash, round robin, and replicated. Each one has a important use case. Okay. Uh, One word answer to you, as of not to disappoint you,
Yeah.
meaning typically you want to, if it is just about an ingestion, it's round robin. If it's a fact table, you would typically go for hash, and if it's a small table, it will be replicated. So it's 10-second answer. But
Yeah.
I have a session coming up on probably on the next round, where I will probably show how you can tune some of these workloads specifically inside data pools. So the first session was to give you an overview with with entire Azure Synapse Analytics. Second session, inside data pools, how do you distribute the tables? How do you tune? What are some of the common problems that you would face when you go production? Okay, so just to uh, I'm I'm working on one of the biggest implementations of Synapse in the world. Okay, so one of the huge customers managing lots and lots of hundreds of uh, data factory pipelines,
Yeah.
thousands of tables, massive amount of data, hundreds of several users directly trying to hit lots of applications all into one Synapse workload, which is doing very well. They had the customer had their issues. We did some lots of fixes. There were quite a few things that we did to tune the database, and then and they are able to do some amazing stuff with the product. So that's something I want to share in the next session. Yeah, hopefully.
Sure. Yeah, because my question was related to more on production side, you know. Yeah. So what I mean, like, yeah, okay, sure. Maybe I think next session will
Yep.
go on. Okay.
So
Thanks. I think maybe I'll just share our next session is. Let
yeah,
me share my screen.
and my apologies to Shane for overrunning. So
No, that's fine. I think.
No, that's fine. That's very fine. It was a very interesting session.
thanks, Shane. Good luck. Yeah.
Hi,
Thanks,
Shane.
man.
Yeah, just a minute. Okay. Hi guys, if please there is a feedback URL, so please help to provide your feedback for the session. So it helps us to improve. It helps us to improve the sessions and it's like what we can do better.
So I will also share my mail ID. I'll tell you why. Okay. So if you have a good feedback, put it in the feedback URL. If you have a bad one, just mail to me.
I think yeah, it was really nice session. So please helps to provide a feedback. Our next session is Shashane. He is a DBA at Compass Education from Australia, and he have very interesting journey from from salesman to I think DBA, and he have done a very long journey. So yeah, I will not take much time about him. So maybe over to you, Shashane.
Thank you, Asif. Thank you so much. All right, let me start by sharing my screen.
Yeah.
Give me 2 seconds. Share screen 2. There we go. I just want to start off by apologizing for my webcam. I know the quality is not that good. It's the best I could get. Most of our webcams are not being shipped to Australia at the moment because of the whole COVID situation. So this is the best I could do in such a short time. So welcome to my talk. The reason why DBAs just can't get over window functions. To start off, just a little bit about me. My name is, like I said, Shashane Welgama. For short, it's Shane. My friends call me Shane. I work at a business called Compass Education. We make school education software for schools, primary schools, and secondary schools in Australia and Europe. I am a Microsoft Certified Solutions Associate in SQL database development. And like Asif mentioned, a few years ago in university, I used to be a robotic Roomba salesman. And also I was working part-time as a level 1 service desk. And from there, I made the push to database administration at Compass. And I've been there for about 2 years now. So yeah, that's just a little bit about me. And yeah, I'm based in Melbourne, Australia. So I might go through a few sections a bit quickly, just because I want to make some time for the use case at the end. And we'll go through the important stuff, and hopefully the main goal with this presentation is by the end of it, I want all of us to be like somewhat comfortable with the window functions and how they work and how we and why should we use them. How can we make them, run faster? How to optimize them, and just to understand how they actually work, like with different in different use cases. Some of the use cases we'll be going through is like removing duplicates from data, paging, running totals, that kind of stuff. The book that I have on the screen, let me get my pointer. Hopefully you can see that. The book that you have here on the screen is by Itzig Ben-Gar. I used this as a huge learning material for myself. Some of the demonstrations are from the book as well. So if you guys want more in-depth analysis, do check out this book. And honestly, I recommend a lot of material by Itzig. It's really great stuff, really, really educational. If I'm talking too fast, or if you want me to slow down, or if you have any questions, please feel free to write in the chat, or try and ask it, whatever. I'm happy to stop and answer, and I'll do my best to answer the questions. Right, so we'll start with what are window functions. Basically, you can think of them as functions that are applied to a group or set of rows. So essentially, that group or set of rows is a window, and we use the term window as like just the set of rows that give that we apply that function to. And when I say function, I mean it can be some familiar ones like max, min, count, or it can be some ranking functions like rank, dense rank. There's many different types of window functions, and depending on what you want to do, you can use different ones, and they're all documented on Microsoft documentation. I won't go through every single one of them. I just want to get the idea across, and we'll go through some examples as well. So here I have a quick example of using the rank in a window function, the rank function in a window function. So the window function is actually this whole statement right here. So this whole statement here is actually the window function. It incorporates a function. So this could be max, min, count, whatever. In this case, it's rank. And then it's followed by an over clause. And then in that over clause, you can have a few different inputs. Generally 3 inputs. It's partition by, order by, or rows or range. I'll get into that all in shortly. But this is a quick query just to show how the structure and the syntax of a window function. The over clause is actually what you use to specify the window that we are operating on. And that will also make sense soon enough. Quickly here, I have a screenshot of a table from Stack Overflow. It's just a random table. The main point I wanted here to show is that, like I said, the over clause creates a window for the function to be applied on. So essentially, whatever the over clause is, this rectangle.
Oh, I think there is some disturbance. Maybe it's. Yeah, I think there is some connectivity issue.
I'm so sorry, guys. Sorry about that, guys. Apologies. My net got cut off. Can you guys hear me?
Yeah, can.
Yeah. Apologies for that.
No, sure.
Let me share my screen real quick. Was it on this screen that you guys lost me?
Yeah.
Yeah. Okay. Apologies again, guys. All right. I fixed my internet. Should be good now. Yeah. Sorry. So with this is a quick example of the over clause and how it creates a window. We'll move on. And something else actually I wanted to just point out, each row has its own window, and that window is independent of other rows' windows. So there's no overlap between the windows. That'll make more sense within the presentation, within the demonstration. Elements of a window function. There's 3 elements generally for a window function: partitioning, ordering, and framing. They are represented by the 3 inputs for the over clause. Partition by is for partitioning, order by is for ordering, as that makes sense. The row and range is for window framing. The row and range one is a bit tricky, so I'll showcase that better in a demonstration, which comes very soon. Partitioning data, when we're using, you can think of the window partition as a filtering layer. So it's supported throughout all window functions. And so basically, you can think of it as grouping records. If you don't specify the partition by, the window is considered as the entire result set, because there's no window, there's no restriction to the window because you didn't specify a partition by. In this example here, there's 2 rank functions. So there's essentially 2 window functions. One with the alias of rank all, so that's the 4th column, and one with the alias of rank customer, which is the 5th column. What I'm trying to showcase here is how the ranking function operates when there is no partitions and when there is a partition. So the the first case where there is no partition by declared, there's no the whole result set is taken into consideration. This result is actually about 830 records. I only showed 10 records here because I'm not going to show 830. And you can see in that fourth column, the values are representative against the entire 830 columns, 830 rows, whereas the final column is representative within the partition. So we partition by custom ID. Custom ID is 1 in this case. They're all grouped here, and we're given a rank to how they're placed with the order by ordering the value descending. And as you can see, it's 1 to 6. And then when we go to the new partition, it's reset to 1 to 4, right? Because that's a new partition because custom ID is now 2, right? Ordering, I'm sure it's very straightforward. It's you're ordering the data, but just as a note, in aggregate, when you're using it for aggregate functions, it's not exactly that straightforward. It's more of a helper for window framing, which acts as another filtering stage, but that all makes sense with the demonstration, which will be very shortly. Windows framing, again, you can think of this as the secondary filtering layer for the window function. Basically, you have a window that's defined by the partition by clause, and then in the partition by clause, you can have more restriction of rows. You can think of it as a frame. So a frame is within the window within the window, and that's the syntax of it. But right now, instead of just showing screenshots, let's get into it. Here we are. Let me just take care of this. Yeah. OK, so this table here, it's a very simple table, 3 columns, name, sex, and salary, and there's 16 records. Now, and you can see that there's it's very straightforward, nothing much to explain about that. Finding the running totals and group them by sex. That's a task that we have to do for this result set. So to find the running totals, I would like to add up the records one by one after each other. So I'll use sum. So what I do is I write a query, select name, sex, and salary. OK, 3 columns. I put sum. I use that for the window function. I add salary as the column I'm trying to do aggregations on, because I'm trying to find the running total for salary. And then I order the data by salary as well. Now you can see in the data set, I have a 4th column that's derived from the window function called running totals. So you can see in the first record, it makes sense, right? Saman, male, salary is 1,000, running total is 1,000. All right, that's normal. Then Dostal, male, salary is 2,000, running total is 5,000. That doesn't make sense, correct? Because the running total should be around 3,000 now, but we have been returned with 5,000. If we go to the third record, Chintan, salary is 2,000, running total is 5,000. That's correct, because 1,000, 2,000, 2,000, 5,000, right? So why is Dostal 5,000 as well? Well, it's due to the fact that this is actually due to framing. There is framing applied here, even though we didn't use the row or range clause in this query. Because when you write a query like this, a function like this, there is a default value given to the row or range clause. And that is this, range between unbounded preceding and current row. That's the default value. So if I run both these, you'll notice that both result sets are the same. There's no difference. That's because they're the same query. Just one of them, the default value, you just don't see it. So what does that mean? The range between unbounded preceding and current row. Range, the keyword here, the main difference from using range and rows, right, is that range treats duplicated records as one entity. So it will treat the salary value 2,000 of Dostal and of Chintan, which is 2,000 as well, they're both seen as by SQL Server as one entity when you use range, right? Now, so the highest computed value, which is 5,000, because when you do 1,000, 2,000, 2,000, it's 5,000. That value will be shared between the two duplicated values, because using range, SQL Server sees the data as one entity. Essentially, that's what's happening here. So how do we fix that? Because obviously this is wrong. If you're creating a query for reporting purposes, or it's incorrect. So how do we go about fixing it? You use rows. Rows, when you use that keyword instead of range, what happens is each record is seen as a unique record. It's not taken, even if it's duplications, it's not taken as one entity. So if I run this, just this query with so I'm taking out, the only difference is I've removed range and applied rows. So you can see now when we do the running total, as we go down, it's absolutely correct. Dostal is 3,000, Chintan's 5,000, Dev is 8,000, and that's correct. As we go down, it just keeps adding on. So now we have created a running total. So we've done like the first half of what we're set out to do, because we're trying to find the running total and then group them by sex. So now we do the second part. Now to group them by sex. Sorry guys, give me 2 seconds. Sorry about that. We have to use the partition by clause. We haven't used partition by earlier, right? That's why the running total just keeps going throughout all the records, because like I said before, if you don't put partition by, the whole result set is seen as one window. So now we want to actually create grouping for the column sex. So we use the partition by clause, right? So we write this query here. We partition by sex. Now you can see the partition by clause has created these windows, one for female, one for male, and one for other on the bottom here. Right, but now again, I forgot to put in rows between unbounded preceding and current row, because if we don't specify, it's range. And that's why you can see for 7 and 8, salary 2,000 is 5,000 for both, which is not ideal. So here I've added the proper value for framing. And now you can see that in these windows, the running totals are going as expected. And when we come to Rashmi, here is the last record in the female window. When we go to Saman, you will notice that the running totals have been reset to Saman's salary. And that makes sense, because now we're looking at a new window, right? The windows are independent of each other. So you can now start to see some analytic purposes for window functions. Well, I hope it's a good showing so far. But now there's a bit more. So now this pretty much answers the question of finding the running totals and group them by sex. Now we can actually play around with the rows and range, the framing a little bit more. There's a bit more detail with it. So what you can do is, instead of saying rows between unbounded preceding and current row, because what that means is, let's say if I'm on row number 3, Hasini, rows unbounded preceding is everything beforehand, and current row is Hasini, which is row 3. That's the frame, right? So we can play with that frame by doing between one preceding and one following. Let's run that query. What we have now is, let's look at the first query. Amanda, salary 5,000, running total is 11,000. What happened here? One preceding is null. One preceding means one before. There's nothing there. One following is 6,000. 5 plus 6, 11,000. So if we go to Hasini, that's the 6,000 here, 7,000, 9,000, 22,000. So we started making a more restricted frame within the window. And if we go to Rashmi, again, the last record within the window for the partition female, you will notice that 10,000, one preceding is 9,000, and one following is 1,000. All that together is 20,000, but that's not here. Here's 19,000. Reason being is that since the framing only works within the window that it's operated in. So this record is in the window of partition by female. So it will not. So one following is actually null because it doesn't go here. Proceeding only 19,000. So I hope that made a little bit of sense, and I hope you can start to see now some capabilities of using this window functions for like analytic purposes. That's a quick basic showing. Let's go back to the presentation. I might move through a few things here a bit quickly, guys, just because I'm wary of time. Okay, like I said, difference between rows and range. Simply put, rows is the duplicate values involved. They'll treat them as separate rows, separate values. Range is seen as one entity for duplicated values. That's basic understanding. Types of window functions. There's aggregate, ranking, and analytic functions. Aggregate functions are, I'm sure you guys are familiar with. It's your like average, count, min, and max. Sorry, apologies. Let me get the pointer out. Yeah, count, min, and max. I'm sure you guys have used that plenty of times when you have written group by clauses. And some of you might be thinking, why would you do partition by, not group by? What's the big difference here? There's actually quite a big difference with group by. What you notice is that when you get your resultant set, the rows collapse onto each other. And generally speaking, that might not be what you want always. You might want to see the details. So you might want to, when I say details, I mean each column and then having each row having a aggregate value per row. You can get that with window functions. So group by doesn't give you that. Yeah, so aggregate functions, I'm sure you guys have used them plenty. These two examples I have here, these two queries. Left-hand side, I have aggregate function average used within subqueries, and I have the same aggregate function used within a window function. Both these queries give the exact same result set. Let me show it to you guys. Hold on. Yeah, so basically, I'm using this table here called films. It's just 6 records, nothing much, right? It's a tiny table. Basically, each row is representative of a movie, and the release year, the category, so horror, action, whatever it may be. One can be horror, that's representative, and then the rating for the movie, right? So very simple, simple example here. Now, what I want to showcase to you, I'm going to show you these two earlier queries that we were looking at, where one was they were both given the exact same result set, but one was using subqueries, which is this one over here, right? Subquery option, and the other one is the window function option. Both of which give you the exact same result set, right? So you can see right here, they both have the exact same result set. Basically, I'm doing an average on the rating for the year and then the average for the rating for the category, right? Nothing crazy. So now, when people see this, they notice one thing, obviously, is that, yeah, it seems more concise, the window function pathway, when you write the code, and it is. The other thing they think about is which one performs better? Performance-wise, what's better here? Let's look into that. So set statistics time IO on. This is just a command. I'm sure you all may have seen this once or twice. It's just gives you information on what is how many logical reads are going on and the CPU time that's running for these queries. This table is very tiny, like I showed you. It's just 6 records. So CPU-wise, we're not going to see any difference. So this over here is the traditional SQL, so subquery option. This over here is the window function option, right? So you will notice that, apologies if you can hear the commotion from the road. Sorry for that. What you will notice is that logical reads are significantly less in the, not significantly less, but less in the traditional SQL where you use subqueries compared to the window function option. And just so we're all on the same page, one logical read equals to about 1 8 kilobyte of a data page, or 8 kilobyte page, and that's read in memory, right? So 26 logical reads are needed. 26 pages is needed for traditional SQL, and about 52 in total are needed for window functions. Now, you might tell me, just judging from this, the traditional SQL is more, it's better. It runs quicker. Now, you're not entirely wrong. My argument to that personally is, obviously now looking at this, these are very small numbers. They're both very fast, but let's say there were a bit more of a drastic difference. My argument to this would be the traditional SQL path is better if you had an environment that has higher memory pressure. If you're in an environment that had, let's say, high contention, like a lot of lock-in happening, a lot of, let's say a lot of lock-in, a lot of contention, I would then say the window function option is a lot better for you, because 2 logical reads are done on the films table, whereas 50 of the logical reads are done on a work table. A work table is a table in tempDB. So for an environment that has a lot of lock-in issues and not much tempDB contention, the window function option might be better. If you have tempDB contention, or if you have memory pressure, then you could go with the traditional SQL option, which is subqueries here in this case. But yeah, keep in mind both these are running really well. Personally, I think just running this is much simpler, and it's also easier to read and understand what's going on. When you read this query, you're able to easily understand and know what you're trying to do, rather than seeing every subquery here. But each their own, anyways. Okay, that's a quick thing I want to show about performance between these 2 functions. Okay, quickly with time. Ranking functions, as you know, you can imagine what it means. These are functions that you can use to for positional or to rank records in a window. Row number is one of my favorite window functions to use in a window function, because it's very versatile, and both my use cases, I'm going to show you in just a bit, my real world use cases use row number. And I think it's widely used. I think it's very useful. Basically what it does is it puts a number, it identifies the record as row number 1, row number 2, 3, 4, 5, 6. That might not sound very useful, but believe me, there's a lot of use cases you can use for that. Analytic functions are, as you can assume, they use for analytic purposes. Here we have lag and lead. To put it simply, lag is every value that was in the previous record. Lead is in the values in the following record. This column here is previous for the lag. Oh, you can't see my pointer. This column over here is for lag. This column here is for lead. You can notice in the first record here, I use lag, and it doesn't get, it gets now because there's no records before that. If I go to the second record, it gets 814, right? Because that's the previous value, and vice versa, same for the lead. I'm going to quickly go through this because I want to get to the use cases. Now, benefits of window functions. As I said, they're easy to read syntax. When you do get the hang of it, they're a bit more easy to read than your, than a common tables expression or than a subquery. It does not require group bys. They show the details, like I mentioned as well, so they don't collapse data when you execute it, like a group, how a group by would. You can actually see each record by itself, which is really cool. Encourage use set-based operations, which normally runs for better queries, and also it saves you with coding as well in terms of time, because it's quicker. You can write it quicker. This is a quick example I wanted to show with the differences in the different tools we have. Like in SQL Server, we have CTEs and subqueries, like I mentioned. Over here, all these three queries, all these three SQL code blocks give you the exact same result set here. This one over here is obviously a CTE. This is the subquery option, and on the bottom left is the window function option. And this is just to drive home the point that it's just so much more convenient and concise using the window function option. But like I said before, they might perform slightly differently in different ways. Depending on your environment, you should go with what's best for your environment. Now, indexing guidelines for window functions. So when you run your window functions, if you look at the execution plan, you'll normally notice there'll be a sorting operator. That is due to the partition by clause or the ordering clause that's within the over clause of the window function. If you want to, reduce that and reduce this, because sorting operations are very CPU intensive, not always, but they can be. The way you can actually fight that is not to your traditional indexes that you would normally create, where you have, the where clause in the index key and just everything else, or the join clause or the join column. It's a bit different. The author of this book, Itzken, he created this topic called POC indexes, this concept. It stands for partitioning, ordering, and covering. Basically, the gist of it is you can see the syntax I have at the bottom here, on the bottom. Basically, it's the same thing, create index name on table name. In the table, in the index key, you put the partitioning column and the ordering column, and then you follow with the include with, whatever you need to cover in the included columns. If there is a where clause in the select query with the window function, you would prioritize the where clause as the first column, and then that's followed by the partition column, and then that's followed by the ordering column. Real world use cases. I have two here that I just want to show you guys real quickly before I wrap things up. Right, so removing duplicates. I'm sure removing duplicates we have all faced at least once. There's many ways you can handle it. One way I like to use is window functions. Let me quickly show it to you. Give me 2 seconds, guys. Just got to set up the data. There we go. And that should be right. So this is just, each record here represents a order. This is just ordering from, this shows order details. Now there's duplicates in this table. This table has 855 records. There's duplicates in the record. There's duplicates in the table. Let me just quickly check something. Just 2 seconds, guys. Yeah, perfect. All right. So an example of one duplicate is this table, with order ID of 10,250. As you can see, there's 2 records here, and they're exactly the same. Now, we don't want that, right? Because we don't want duplicated records in production data, or wherever this may be. Now, how do we go about removing how do we go about identifying the duplicates, and then how do we go about removing them? It's a 2-step process. So first, we'll think about identifying the duplicates. So we can use the row number clause. I told you this is one of my favorites. What we're doing is we're going to partition the data by order ID. Why we partition the data by order IDs? Because we're going to group up the order ID values, because if there's duplicates, we're going to group them, and then we're going to give each of those. So that'll be a window, right? If there'll be additional values if there's duplicates, that'll be. Let me show you. I'm not doing a good job explaining that by words. For example, 10,250, as we saw earlier. There's 2 records of it. This is one window. So that means row number will go 1 and then 2. It'll number the duplication greater than 1. And if there's several more, so let's scroll down. Here we are. 10,300 has 3 records. So there are 3 duplicates. There's 3 duplicates. And then row number will, in that window, specify 1, 2, and 3. Right, so now we have identified what records are duplicated. And now how do we go about deleting them? Well, it's quite simple at this point. We just know that now to delete the duplicated records, we delete the records with n greater than 1. So we create a CTE, add the window function query within the CTE, and then write delete from CTE where n is greater than 1. Doing so deletes about 25 records. And if I go back to this table and have a look, there's only 1 record left over. So it's a pretty simple, quick way to do it. And yeah, so that's one quick way you can use window functions. And then for my last example, let me quickly show you guys the next slide. Paging. I'm sure we're all familiar what paging is. It's a common in many applications. Basically, you know, for an end user, you don't want them to see, you don't want to return 1 million records to them, because obviously that's quite, you know, returning 1 million records to the UI is a bit, you know, it's who wants to see that many records on one screen. So you can break that down into like 25 records or 20 records or 30 or 50. That's paging. So you can use window functions in that case as well. Sorry, here we are. So I created a index to speed up the process. Just let me check this there. Yeah, perfect. All right. So basically, this is the code that that we can use to do paging. Basically, I've created 2 variables, page number, page size. These can be inputted on the fly. Here it's hard coded. So the third page and each page is 25 records. I believe there's again 830 records in this table. Yep, 830 records. And now what I did was I numbered each record. So you can see row number here. Each record is numbered 1 to 830. And then what I did was I put into a CTE again, and then I selected each column from the CTE where row number between. This is a quick calculation to get the 25 records that are on the whatever page that I specified. So in this case, if I put page 1, I should see the records from row 1 to 25, which I do. So it's 1 to 25. If I wanted to see the third page, you put third page there. Now you'll see 51 to 75. So on and so on. You can justify. You can change the parameters however you want, and you will get your paging. So these are 2 quick, and again I use row number here as well. So you can see how useful row number is when it comes to use cases. There's many use cases you can use window functions for. You can get very creative. That's a really cool thing about window functions. Why I really like it. It shows a bit of you can be a bit creative with how you want to do things, because there's so many different types of window functions that you can use, and it really changes the way you write your SQL sometimes. So I really like it for that reason. And obviously I've shown you guys already running totals. We have gone through a few examples of that already. Sorry for making this quick, guys. I just wanted everybody to, I know it's getting quite late here as well on my side, so I wanted to make this a bit quick. Thanks for listening, and thank you, Piao, and thank you, Asif, for organizing this event. Sorry for dropping out halfway through. And if you guys want to follow me on Twitter or check out my blog, it's a bit dry at the moment, but I'm working on it. And email me and give me any feedback at all. I'm looking to improve. If you wanted better examples, if you wanted more in depth in a certain area, if you think I rambled on a topic that wasn't that, on a certain part that wasn't that good, please let me know. I'm looking to improve.
Yeah.
Thank you for your time.
It was really nice session. I have one question.
Yes, questions. Yes, questions. Yeah.
Actually, do you suggest any Windows function which is good for doing statistical analysis or something related to that? Suppose if I want to, how you showed the example of following my orders. And if we want to do something related to ranking in terms of percentile or in terms of ordering or doing some statistical analysis on that.
Yes, there are actually ranking functions that are designed specifically for that purpose. I believe it's called hold on, let me quickly check it out.
Hi guys, if you have any questions, please feel free to ask. And there is also, I think my colleague have already put the feedback URL. So please help to provide a feedback. So it will help us to improve the session. So please help to provide a feedback. Yeah.
Yeah, I believe you could use a percentile continue and percentile discount, and percent rank for those statistical purposes. I have to do a bit more work onto those, but yeah, these might be useful. This might be useful for those purposes.
Okay.
Yeah.
Thanks, Shane.
No worries. Awesome. Yeah. Very true. Very true. Very true.
Yeah, exactly. Yeah. True.
100%. Any questions to the room? Anyone has any?
I think we don't have. If you have, hey guys, if you have any questions, so you can reach out of us and any of our colleague, or maybe you can also email to Shane. He already shared his email.
Yes.
And we are planning to have our next session in next 2 weeks. Most probably will be 11th of February. So yeah, we will announce soon. And yeah, that's for today. Pio, you have any announcement or anything? Okay, thanks everyone. Thanks for staying late today.
It's been before COVID hit. Before COVID hit. Yeah. It's been a long time.
Yeah, thanks everyone.
No problem. Thank you for the session. Thank you for organizing the meetup. See you, everybody. Good night.